Welcome to the Crazy Hat Chemist. So another video here on Thermochemistry. So let's get moving. Bam! So today we're talking about a heating curve calculation number 1. I've got a number of these calculations to do because you need lots of practice. So I'm going to read the question for you. It says, how many joules are required to change 10 grams of ice at 0 degrees Celsius to water at 20 degrees Celsius? So for every one of these problems, what are we going to do? First, we are going to make a generic graph. So here's our generic graph right over here. And what we want to do is figure out where our low temperature is and our high temperature is and associate that with a state of matter. Okay, so our low temperature is at 0 degrees Celsius. Now, that's a funny temperature here in that there can be two different states of matter that are occurring at 0 degrees Celsius. That can be either the solid or the liquid state at 0 degrees Celsius. So you got to pay particular attention to the words here, and it says that it's ice at 0. So that means that it's on the horizontal section of this graph, the lowest horizontal section on the far left-hand side of that horizontal line, right there like that. Hopefully that makes sense. So that is at the melting freezing point, and it is a solid, that is ice, so it's far shifted to the left of that line. Now, if I shift it to the right of that horizontal section, then it would be, if I shift it far to the right on that horizontal section, then if that dot were there, then it would be liquid water at 0 degrees Celsius. But we're not there, we're at solid water at 0 degrees Celsius, so that dot is shifted to the left of that first horizontal section. Now, the next part that we need to do is we need to point in the high temperature. The high temperature is at 20 degrees Celsius. So it is most certainly beyond 0, but it is not at 100, and it is certainly below 100. So you can do an approximation here. This is not accurately, precisely a perfect graph. It's just you need to place the dot approximately where it goes, and that would be a good spot for it right there. It's above 0, it's below 100, perfectly fine. So what steps of the reaction are we going to be doing here? So you looked at the generic heating curve video prior to this and those constants. And then from that information, we're going to do steps 1, 2, 3, 4, and 5, or a small number of those steps. So which steps are we doing in this problem? We're doing step number 2 and step number 3. So there's a specific constant for each steps that we have here at step number 2 and step number 3, and I gave that to you in the generic heating curve video previous to this. Okay, so check this out. Here is step number 2, and this is all based on the constant that I have highlighted in yellow here, which is the heat of fusion. Okay, and that is 6.01 kilojoules per mole. And from that, we're going to take our 10 grams of water, that's H2O, that formula, and then we're going to cancel out the units where we have grams, and that 18.015 is the molar mass for water, that's H2O, that's equal to 1 mole. This will allow me to cancel out moles under the constant where the moles are. And I'm going to convert the units to joules here to make the answer in the appropriate units. You could have left it as kilojoules, but I'm going to convert it to joules. That's step number 2. Step number 3 has a different constant, and it actually has a change in temperature. So here's step number 3. Step number 3 is all based on the constant, and the constant is the specific heat capacity for water that's a liquid, and that number is 4.184 joules per gram degree Celsius. So I have my 10 grams of water that will cancel out the grams. Okay, then I have the final temperature minus the initial temperature. The final temperature is the high temperature, that's at the 20, and that's the final. The initial temperature is at the 0. Okay, so they change in temperature. So you should see that all the units cancel out here, and I'm going to have joules for the units for this one, just like joules are in the top one. So I'm going to get the two values here. That's 3,340 joules. I've rounded that to 3 significant figures. That's why there's no decimal in this number, and that 0 is there, but it does not count except for a placeholder, meaning that there is no decimal beyond the 0. Then the second one is 837 joules. That also has 3 significant figures there for that one. Okay, so now what we're going to do is we're going to sum up these two values, and that will be the total amount of heat content necessary to go from the one step to the next step. And that is 4,180 joules. Notice that in the ones column where the 0 is, that 0 does not count. It is a placeholder. Okay, so it requires 4,180 joules to take 10 grams of ice at zero to increase the heat all the way to 20 degrees Celsius. Okay, I'm hoping you enjoyed that video, and I got a great hat for you here. I got this from a former teacher here at the school that I work at, and he worked for a computer system, and this is for a Cisco Systems here. Give me a thumbs up, subscribe to my YouTube channel, and find me on the web where you can find my website with lots of videos and great worksheets. I'll see you next time. Bye for now.